everyone, welcome back to my channel Cis Theta Learning, and we'll continue our study on system design. And today we are going to cover it's a topic which we study even in programming, so that's abstraction. And what I've planned today is we'll relate our concepts to games, real world systems, and especially one of my favorite games of all time, GTA. Yes, GTA Liberty City, Vice City, San Andreas, or GTA 5, or let's wait for November 19 for GTA 6. But honestly, games are secretly full of incredible software engineering ideas, right? So in today's video, at times that's related to it. And in this video, right, I've already written down the notes to save some time, and I'll share this if needed. So you know what's crazy in GTA, right? When you press F, you enter a car, right? When you press F, you can take a car, and so in one button your character enters a car instantly. Simple, right? But behind that single action there's actually animation systems, there is collision detection, vehicle logic, sound systems, physics, camera handling, and many more things all happening together. So, and yet the player never thinks about any of that. So that is called abstraction when we relate it to the gaming. And honestly, abstraction is probably the reason modern software engineering even works. And since GTA is one of my favorite games of all time, I thought why not use it to understand system design concepts. So think about this. When you use Instagram, you don't think about servers, databases, caching layers, distributed systems. No, you just upload a photo. And even when you order food online, you don't think about payment gateways, API, what API calls are happening, message queues. You just press order. Thankfully, nobody says, please wait while we initialize distributed infrastructure. Abstraction hides complexity, so humans can focus on goals instead of implementation details. So what exactly is abstraction? Okay, so abstraction means hiding unnecessary details so we can focus on the bigger picture. Now let's take this example. Imagine I draw some bird. I'm not very good at drawing, but yeah, something like this. So imagine I draw a bird, not a specific bird, not its feather structure, not its DNA, not its exact pieces, just a simple bird shape. So that drawing is an abstraction because now we can discuss the general idea of bird without getting lost in details, right? So if I started discussing the feather structure, so feather structure, bone structure, or molecular biology, we would completely lose the main idea. And software engineering actually works exactly the same way. So now let's go back to GTA. So when you press F to enter the car, the player only sees this. You press F and you enter the car. Very simple. But underneath underneath that you have an input system. Then you have character interaction. You know, right? There, when you take this GTA 5, you have three characters, main three characters. So, or maybe when this let's take a character Michael, right? Michael in GTA 5, he walks on the road, or maybe there'll be interaction, right? So then he'll drive the vehicle, then there'll be animation. So these all things are there. And even when you take a multiplayer game, right, you need network synchronization. So what happens there? So the game hides all this complexity behind one simple action, that is abstraction. So now we got to know what abstraction is, but why software engineering needs it. Now let's see. Imagine creating this your own operating system, networking stack, database, own graphics engine, just to build one app. That would be okay. I've written it impossible. That's not impossible, but it's time consuming, right? So instead we will use abstractions. So we have these libraries, framework, database. We'll cover everything. Cloud services. We'll cover this in the future videos. But these are the tools. Now these are what are these? These are the tools that expose simple interfaces. So while hiding massive internal complexity, which is honestly great, right? Because I don't want to build an operating system before making an to-do app. So that's the idea. Let's take database. Databases are a great example, right? Now let's say if you want to transfer money between two accounts, as developers, we don't manually manage locks, concurrent writes, disk recovery, cache consistency. I hope you have studied these in database management system subject, right? So instead databases give us something called a transaction. We have studied this transaction. So if not, you can just Google it out. Very important topic in DBMS. So yeah, we have transaction, right? So we have a simple interface where we say begin, transfer money, commit or abort. That's abstraction. So the database hides all the things that are underneath, so developers can focus only on the business logic. So without this abstraction, every developer would have to become a database, what we see, database scientist maybe, just to build basic applications. So let's come to distributed system. So since it's system design, right, we will be discussing this in detail. So in distributed systems, now things get even more interesting in distributed systems, right? Modern apps don't run on one computer anymore. They run across multiple servers, regions, databases, sometimes across entire planet. So when we speak about databases, right, I just want your people to read about something known as seismic racks. Seismic, I think so. The spelling is correct. If that's wrong, forgive me. But seismic, something related to earthquakes, right? Just read about this. It's a good thing to read about. So yeah, so multiple servers, regions, multiple databases. This is complexity is insane. So cloud providers have come in like AWS, Google Cloud, Azure. They provide abstractions on top of infrastructure. For example, instead of manually configuring physical machines, right, developers just click, they just click create database, right? Create database, and suddenly you have all the things that are needed: replication, failovers, backups, scaling, everything that is needed, right? And these are handled. So the abstraction hides the infrastructure complexity. Honestly, modern cloud platforms are basically press button, distributed systems happen somehow. And honestly, without abstraction, modern software would collapse under its own complexity. So abstraction, why abstraction? What does it allow? So it allows the engineers to build faster, scale system, reuse tool, focus on higher level problems instead of constantly reinventing low level systems. And it lets human think at higher levels, right? So, and that's one of the reasons modern technology evolves so fast. And this becomes even more important in networking. So why networking? Because in distributed systems, you often want to communicate to feel simple. And even when machines are talking across the internet, and that leads us to one of the most important abstractions created. What are those? Those are RPCs, remote procedure calls. So this is what we'll cover in the next video, because multiplayer games like GTA are basically full of RPC calls happening every second. And also, as I mentioned earlier, I've already made some notes and diagrams while preparing this video to save time during explanation. So if you want those notes resources, let me know in the comments and I'll share them as well. Maybe I'll create a repo, Git repo, where you can access all this. And if you enjoyed this video, do like, subscribe and share it with your friends. See you in the next one. Thanks for watching. Bye.